In this particular video, we are going to focus on how you should answer questions to do with impulse and momentum in Cambridge exams. So if you are doing EDEXCEL, there is a link that will take you straight to the tutorial I've done for momentum and impulse for EDEXCEL, but for this particular video is for Cambridge students. Is that momentum is given by the formula mass times velocity. That the SI unit for this is kilogram meter per second, which impulse is given as force times time. Impulse can be defined as the product of force and time. And also we can be able to say impulse is equals to change in momentum is given by mass times final velocity minus mass times initial velocity, be mass into v minus u. So anytime you'll be working out a question to do with impulse, you'll understand that impulse is change in momentum, which can be worked as m into v minus u. So this is quite important when you are doing Cambridge physics, and we're going to look at the past paper questions that have been asked for this concept, so that you can be able to know how are you supposed to approach questions like that. And the most important thing that you need to remember in this area is that you need to know which formula to use when. If you are given force and time in a question, you will use this particular first formula that we have. So in a question, if you are given velocity and mass, you are going to use this second time, even though we are talking about impulse. So this is the second concept also that is very important for Cambridge physics. The law of conservation of momentum, you must know how to state it. That momentum, total momentum before collision is equal to the total momentum after collision. As long as you are going to do question to do with this, we are going to see how to use this concept maybe when you are considering objects that are moving and colliding. Let's now dive in so that we can be able to see how are you going to answer question to do with momentum. At the end of this video, I'll also talk about one of the concepts that is also confusing, where students confuse between this one and that topic I'm going to talk about. We can also define impulse as the change in momentum. So looking in question number 2, we're told the diagram shows athlete crossing the finishing line in a race. As she crosses the finishing line, her speed is 10 meters per second. She slows down to a speed of 4 meters per second. So meaning that 10 meters per second is the initial velocity, and 4 meters per second is the final velocity as the athlete is crossing the road. And then we're going to work out the impulse applied. Now, since in this question we have the mass, we have initial velocity, and we have final velocity, then it will mean that our calculation for impulse will be based on the change in momentum. And we say that change in momentum is equal to impulse. And we also need to understand that change in momentum is the final momentum minus the initial momentum, and then you can be able to apply the formula. The answer is going to be 426 ns. Newton second is the unit for impulse, and you need also to understand that in this case we are trying to talk about change in momentum, so there's no need for us to have that negative sign there. We can write our impulse as 426 Newton second. So that becomes our answer in this case. So the next thing that we are going to talk about is the formula that can be used to calculate impulse. In terms of force and time, that formula is force times time, as shown there. We are supposed to calculate the average resultant force. Anytime you are given a question and you are told to work out average resultant force, that's basically force. And we are going to use the formula impulse divided by time, and that becomes 426 divided by the time in this case, which is 1.2, that becomes 355 newtons as the force in that case. So that's the formula we're going to focus on, and if we substitute it here, we are going to get our final answer as 355. These are past paper questions from Cambridge, and this is how questions are asked, and you really need to understand the concept. I also mentioned when I started this particular video that you need to understand the principle of conservation of momentum, and I say that the principle of conservation of momentum say that total momentum before collision is equal to the total momentum after collision, provided there is no external force. So we need to understand how the principle of conservation of momentum states, because during your exam you may be asked to state that principle. Total momentum before collision is equal to the total momentum after collision. The diagram shows a model of fire engine. Its brakes are applied. Yes, its brakes are applied, and the fire engine model has a total mass of 4 kg and it's moving at a speed of 0.25 meters per second. So this fire engine, as it's moving, remember, any object that is in motion, it has what we call momentum. So in the event you are asked to work out momentum, we need to remember the formula for momentum is mass times velocity. And in this case, our mass is 4 times the velocity, which is 0.25 meters per second. So if we work it out, we're going to get our answer as 1 kg meter per second. To calculate the magnitude of the force to stop it in the 5 seconds, we are going to work out change in momentum. Of course, we can be able to use change in momentum is equals to for impulse. And we know that impulse is force times time, right? And our time in this case is 5 seconds. Now, why are we using change in momentum as 1 kg? Remember, the fire engine was at rest, then it started moving. So meaning initial momentum was 0, then the final momentum is 1. So the change in momentum remains to be 1. And then we can be able to say change in momentum is equals to the impulse. And in this case, impulse is force times time. So it's F times the time, which is 5 seconds. So for us to get F, we have to divide 5 both sides, and this becomes a force of 0.2 newtons. And this now gives the force that is used to stop it. Now, the diagram shows a man hitting a ball with a golf club, and we are told that the ball has a mass of 0.046 kg. The golf club is in contact with the ball for 5.0 times 10 to the power negative 4 seconds, and leaves the golf club at the speed of 65 meters per second. Now, you are supposed to calculate the momentum of the ball as it leaves the golf club. So we know that momentum is mass times velocity. The mass of the ball we are provided, and the velocity at which it leaves we are given. So we can be able to substitute here, and if we work it out, we are going to get us 2.99 kg meters per second. So this is the momentum as the ball leaves the golf club. We're supposed to work out the average resultant force acting on the ball as it accelerates at 6.5 times 10 power 5 meters per second. And we have now, this is as the acceleration. You need to remember that this is acceleration that is provided. It's meters per second squared. So for us to work out the force, we are going to apply the formula force equals to ma. Now, because we have the mass of 0.046 times the acceleration, 6.5 times 10 to the power 5, and this becomes what? This becomes a force of 29,900 newtons as the average resultant force. So you will find that questions will be require you to use the formula force is equals to ma, which is Newton's second law, and also the other concept I mentioned at the beginning of the video. We are told that a footballer kicks a ball vertically upwards, initially the ball is stationary, so meaning the initial velocity is 0. His boot is in contact with the ball for 0.050 seconds. The average resultant force on the ball during this time is 180 newtons. Then the ball lifts his foot at 20 meters per second. We are supposed to work out the impulse. Remember, impulse can be calculated from force times time. So we can be able to use the information provided in this case, and the most appropriate formula we are going to use is this one, because we know the force and we know the time. And if we work it out, we are going to get our answer equivalent to 9 Newton second as the impulse. The mass of the ball, then we're going to use the impulse, the formula impulse is equals to change in momentum. Yeah, so we are going to say impulse is equals to change in momentum, and our change in momentum can be given by this formula, right? Initial velocity of the ball, remember it was 0 meters per second, and final was 20 meters per second. So we can be able to substitute there, divide by 20 both sides. Our answer becomes 0.45 kilograms. Now calculate the weight of the ball, because now whatever we have is the mass. The next thing that we need to do is to work out the weight, and the weight is mg. Yes, you are given gravity to be 9.8, so that also will be depending on what you are given in an exam. So if you are told G is 10, you'll use 10. If you are told G is 9.8, you use 9.8 in this case. So if we work it out, we're going to get 4.41 newtons as the weight. So the next question that we are asked here is to state the factors that affect momentum of the ball. Factors that affect momentum of a ball include mass and velocity. And also in this case, because there could be also the concept of air resistance, because air resistance is going to affect the velocity of the ball and the speed at which it's moving. Complete the table by writing in the right hand column the name of the quantity given by the product. So if we are talking mass times acceleration, mass times acceleration is actually called force. Mass times acceleration is force, but force times time gives us impulse. Now, we are supposed to work out the change in momentum, and something that you need to remember, that change in momentum is final momentum minus initial momentum. And in that case, you are going to say mv minus mu, like that. A racket is in contact for the ball with the ball for 0.006 seconds. And the average force is 400 newtons. Now, to work out impulse in this question, we shall use impulse is equals to Ft, because we have the force and also we have the time. And in that case, what I need to stress most whenever you are doing questions with momentum and impulse, you need to check the most appropriate formula depending on what is given in a question. And then in this case, we're going to get our answer as, if you work it out, you are going to get your answer equivalent to 2.4 Newton second as the impulse. The mass of the ball is 0.056. Now we are supposed to work out the speed at which it lifts. So we can be able to use impulse is equals to change in momentum. And we need to, okay, this is the racket, and the ball will be leaving at v meters per second, but the initial velocity when the ball was on the racket, the initial velocity would be 0 meters per second. Then we can now be able to use impulse is equals to change in momentum, and in this case, you remember initial is 0, so we can be able to now make v the subject and divide by 0.056 both sides. Our answer becomes 42.9 meters per second, which is approximately 43 meters per second in two significant figures. Now, once we have learned how the principle of conservation of momentum works, we can be able to work out questions like this. We are told before collision, the velocity of A is 3 meters per second, but B is stationary at rest. After collision, A and B, they move together, their common velocity, V. Now we are supposed to calculate the momentum of block A before collision. Remember, before collision, block A was moving at 3 meters per second, and it has a mass of 2.4. So we can be able to use the concept of momentum, and we are going to say that momentum is equal to mass times velocity. So we're going to say momentum is equals to mass times velocity, which means that it's 2.4 times the velocity, which is 3. And if you work it out, you're going to get 7.2 kilogram meter per second. That is the momentum. But for us to find the common velocity now, we're going to use the principle of conservation of momentum. Momentum before collision is equal to momentum after collision. Now, before collision, B was moving at 0 meters per second. So meaning it was having 0 momentum. So, and this one was, A was having a mass of 2.4, B was having a mass of 1.2. Then we're going to say before collision, total momentum is 7.2. And then the two masses are going to combine, then times the velocity that they will move together. I'm adding the two bodies together, the mass of the two bodies together, because they are going to move with a common velocity. So they are going to move as one body. So divided by V both sides, and then making V the subject of the formula, our V becomes 2 meters per second. Calculate the impulse experienced by block B. Impulse experienced by block B is equal to the change of momentum of B. Because B initially was at rest, initially it was at rest, so its change of momentum will be basically 1.2 times its new velocity. So this becomes what? 2.4 Newton second. As we are asked to state the change in momentum for B, we know impulse is equal to change in momentum, so the change in momentum for B is going to be the same value, which is 2.4 kg meter per second. Now this is the concept that we need to also remind ourselves, that vector quantities are quantities which have both size and direction, and acceleration is a vector quantity, and momentum is also a vector quantity. All this that we are having here are scalar quantities. Now this is the concept that confuses most students. Calculate the moment. Calculate the moment. Here we are not asked to calculate momentum. You need to understand the difference between moment and momentum. Moment is force times perpendicular distance. And if you're working out the moment, we are going to say 700 newtons times 3.5. You get your answer there. So this is the concept that confuses students. When we are talking about momentum is different when we are talking about moment. You need to understand the difference. And then in this concept also you need to understand the concept of the principle of moments. The principle of moments states that at equilibrium, at balance, the sum of clockwise moments about a point, sum of clockwise moment about a point is equal to the sum of anti-clockwise moment about the same point. So you need to understand the difference between principle of moments and also the principle of conservation of momentum, which talks about total momentum before collision is equal to total momentum after collision. You need also to understand how to use the principle of principle of moments in order to work out a missing force like this. So you're going to say clockwise moment is equal to anti-clockwise moment, divide by 1 both sides, and our F is going to translate to 45,000 newtons. And also you need to remember that all the distance should be measured from where the force is acting to where the pivot is. We've come to the end of this tutorial, and you've gotten value from this video. Consider subscribing so that when I'm going to do more tutorials, you'll be notified. See you in the next video.